Alright, how you guys doing today? This is Mr. Muscarella and Pythagoras. Now we're coming at you, hanging out, bringing you live today the sine, cosine, and tangent ratios for this chapter. Now this is often referred to as SOHCAHTOA by many math teachers around the world. And that's really just a mnemonic, which means it's a way to help you remember something. And we're going to be talking about what that helps you remember by using sine, cosine, tan ratios and that acronym. Now this is going to be the first part of the notes for this section. We're going to do examples 1 to 5 in this video, and then we're going to save our word problems for the next video. Alright, so be sure to tune into that one. Now let's go ahead and take a look at what this all means. First we've got to identify, what is a trigonometric ratio? Well, I'm glad you asked. It's a ratio that represents two sides of a right triangle. Now the three basic trig ratios are sine, cosine, and tangent. Now the three basic trig ratios, any trig ratio you're going to set up is always going to be dependent on the location of the angle that you're given. So in the example that's there on the left, you see sine of A, cosine of A, tangent of A. So that everything that is done for this part is done from the perspective of this angle right here, angle A. So if I go over here to that side, that's the side that's opposite angle A. Well, this side right here is going to be the side that's adjacent to angle A. And then, of course, always remember, the hypotenuse is always going to be across from the right angle. So your hypotenuse will always go in that location. Now, if, however, we were talking about angle B, then we'd be looking at everything from a little bit different perspective. Because over here, where angle B is, hypotenuse is still going to be the same. But now this piece over here, that's now going to be the opposite. And this piece right here is going to be the adjacent piece. So it all depends on the perspective of which angle you're looking at. So that's the main thing you've got to do, is pay attention to which angle that you're going to be looking at. Now let's take a look at our first example. It says find the sine, cosine, tan ratios of each acute angle in the triangle. Write each answer as a fraction and as a decimal rounded to 4 decimal places. Well, what I want to do first is actually get everything set up. So we're going to have the sine of A, cosine of A, tangent of A. That's going to be one of our acute angles. And we have another acute angle, which is angle B. So we're going to have the sine, cosine, tan ratios for that angle as well. And then we got to round those things to 4 decimal places. And I'll show you guys how to do that on the handy-dandy TI-8384 graphing calculator. So more on that in a minute. Now, sine is the ratio of opposite over hypotenuse. So based on where angle A is, what I'm going to do is actually just kind of put an O over here where it's opposite, put an H for hypotenuse, and an A for adjacent. And I'm going to do the same thing again for angle B in a minute. So based on where A is, opposite is 8. So I'm going to write 8. And then the hypotenuse, that side, is 17. So that's my ratio, 8 over 17. Now cosine of A, cosine uses adjacent over hypotenuse. So based on how my triangle is set up, my adjacent is the side that has 15, or side AC, and the hypotenuse is 17 again. So that's going to be my ratio for the cosine of A. And then tangent is opposite over adjacent, which in this case is 8 over 15. That's all there is to it. So we've set up the sine, cosine, tan ratio based on where angle A is. But if I had to do this all over again, but this time from angle B, so now I'm dealing with this guy right here. So now 15 is going to be the opposite side because that's opposite angle B. Hypotenuse doesn't change, and then now side BC is now the adjacent side to angle B. Now that I have that set up, all you need to do next is just set up those ratios, and I think you could probably do that on your own. So give that a shot, hit pause, and then come back and see if you got them set up right. And then I'll show you guys how to do that on the graphing calculator. So how did you do getting that one set up? Did you rock it out? Hopefully for sine B, you got the ratio of 15 over 17, opposite over hypotenuse. For cosine, that's going to be the adjacent side of 8, and the hypotenuse side of 17, and tangent, you'd have 15 over 8 for your ratio. So that's how you get those set up. Now the main thing again is perspective. Make sure you're paying attention whether you're looking at angle A or angle B. Now I'm going to show you guys how to graph this on your graphing calculator. So if you have one, go ahead and pull that out, get that ready. If not, you can go ahead and write down everything now, but then make sure you practice it because there's a little bit of button pushing you've got to do here. Now, the calculator is a really, really nice thing because we've got to get it set up first. Now, one of the things that I want to pay attention to is here where it says rounded to 4 decimal places. So I can actually tell my calculator to do that for me. And the other thing that we're going to do anytime we're dealing with trigonometry in the graphing calculator, one of the things that you want to do, and I'm going to make the screen big here so you can see this, I want you to hit the mode button, and that's where we're going to make some changes here. In the mode, the first thing that you want to do is change our decimals because it said 4. So we're going to change in the line that has float, we're going to change that to 4 and make sure you hit enter. So see how that went over to 4? So now that's going to round it to 4 decimal places. But the other thing in geometry that we'll deal with at this point is since our angles are in degrees, we want to change that radian to degree. Now when you're in other courses, or maybe even in your geometry course, sometimes you might have to deal with radians, and they're going to look a little bit different than degrees. That's going to be where you have something like pi over 2 or pi over 4 or pi over 6 maybe. So that's when angles are in radians, but we're dealing with degrees. So the first thing that we got to do is get our calculator set up. Once your calculator is set up, what I like to do is say quit and go home, so hit second and then mode. Now the hardest part here is then just typing these in. So you do 8 divided by 17, that gives you 0.4706. Our other one is 15 over 17, and then we have 8 divided by 17. So go ahead and key those into your calculator, and then what we're going to do is just write those values for sine A, cosine, and tangent A. Now repeat the process for all of the ratios, all of the fractions that are there for sine B, cos B, and tangent B, and write those in as well. So did you do okay typing those in? Now here's something that I want to make sure that you pay attention to. Check this out. Notice the fractions for sine of A and cosine of B. They're the exact same thing. What about the cosine of A and the sine of B? Those fractions are also identical. The tangents are not, they're reciprocals. If you found their product would equal 1. Now here's a common error, and I want you to take a look at the decimal for tangent of B. If this says round to 4 decimal places, and you just write down 1.875, that'll be incorrect because you did not go to 4 decimal places. So don't be careless. Make sure you write down whatever your calculator displays because that's how many decimal places there are for that. Because we don't know what's beyond that. Maybe something caused that to round to a 0, or maybe it didn't. We don't know because we're only looking at the first 4 decimals. So if it says 4, make sure you go out to 4. Now go ahead and try example 2 totally on your own. I think you guys could rock that one out. So hit pause, try that. When you're all done, come on back and see how you did. So how'd you guys do with example 2? Hopefully for sine of r you have the correct ratio of 16 over 65 and a decimal approximation of 0.2462. And then similarly with cosine of r you get 63 over 65 equals about 0.09692, and the same with the rest of the ratios as you go down through there. If you've got any questions about that, make sure you're looking at the angle from the right perspective. Find the value of x and y. Now for this is, you'll see lots of different types of problems like this where you're given an angle and you've got to find a side and another side. So what you've got to do is kind of take a look at the perspective. Based on where 32 is, where this angle is right here, across from that, this is my opposite side. So I'm going to write the letter O right there for opposite. And then the 11, well, that's adjacent. So based on where 32 is, I've got opposite and adjacent. So I'm going to use one of the trig functions that deals with opposite and adjacent. And if I have those memorized already, I'm ready to rock on. But if not, they're there for your reference anyway. Opposite and adjacent has to do with a tangent function. So here's how you're going to solve this type of problem. First thing you're going to do is write down this. Tangent of 32 equals, and then x over 11, opposite over adjacent. Now, The next step that you're going to do, so we're not going calculator yet, and that's where a lot of people make a mistake. They go calculator. You're going to write 11 times tangent of 32. That's going to give me my value for x, because basically what we just did was we multiplied both sides by 11. Now that we've got x by itself, now we're going to figure out, we're going to go to our calculator and actually use that to figure out what the value of x is. So after you have those first two lines written down, then you go to the calculator and you're going to type in 11. You're going to hit this tangent button, so finally you get to hit one of those buttons on the calculator. So you're going to hit the tangent button, and it was 32 degrees, and then we're going to close that. When we hit enter, now we've got this to 4 decimal places, so we're going to write 6.8736. So that's the value of x for number 3. For this one, we've got 32 degrees again, so I'm going to label my sides O, A, and H. Hypotenuse is right here because that's across from my right angle. We're based on where the 32 is, x is opposite, and the y is adjacent. So the only number I'm given is 18, so I'm going to use trig functions that I'm going to have to use that side, h, to find both the opposite and adjacent sides, or x and y. So what I'm going to do is first set up, I'm going to find x first. So if I try to find x, I'm dealing with opposite and hypotenuse. Now, which one of my trig functions deals with opposite and hypotenuse? That's right, that's going to be sine. So for finding x, I'm going to write down the sine of 32 equals x over 18. Now to solve this again, we'll multiply both sides by 18. So I'm going to have 18 sine 32 equals x, and then I'll key that into my calculator and get an approximate value for that. If you keyed that in correctly, you should get about 9.5385. So that's the value for x. Now to find y, and I'm actually going to change colors here a little bit. I'm going to make the adjacent red instead of blue, just so it's a little bit easier to kind of keep track of pieces here. So now I'm dealing with adjacent, and I still have to deal with the hypotenuse being 18, but adjacent and hypotenuse, that's going to deal with cosine, with that ratio. So to find y, this time I'll have cosine. My angle is 32, so that's going to be my adjacent. I don't know what that is yet, that's just y, and then my hypotenuse is 18. By now, I think you guys know how to figure this one out. You'd multiply both sides by 18, come up with whatever the y is, then we would key that into our calculator. So that's all there is to that. Now, when you show your work, this is exactly how I want you guys to show your work. Don't take any shortcuts, and right off the bat in the beginning, hit the cosine button or the tangent button or the sine button. I want you to take your time and do each one at a time. All right, now 5 I think you guys could probably do on your own. Let's go ahead and get it set up together though. Based on where the 48 is, the 10 is adjacent. Now the y is opposite the 48. So what trig ratio deals with opposite and adjacent? Well, hopefully by now you've got that. That would be tangent. Then I've got the x, and then the x is going to be the hypotenuse. So my hypotenuse is here now. Again, what's going to deal with adjacent and hypotenuse? That's going to be the cosine function. So go ahead and set these ones up, figure it out on your own, and then come on back, see how you did for example 5, and we'll go ahead and wrap this one up momentarily. So hit pause, and then come back in a moment. So how did you do with the rest of this one? Hopefully you've got tangent 48 equals y over 10, and then 10 tan 48 equals y. When you plug that into your calculator in degree mode and round it to 4 decimal places, you get 11.1061 for the value of y. Now finding x is a little bit trickier, and this is going to involve one more step of algebra here. And there's going to be a pattern that some of you might pick up on, and I'll maybe do another video just on what that pattern is for that. For this piece, we've got 4 steps. First thing is the setup, which I'm sure you guys are fine on. The second step, since the x is in the denominator, you have to multiply both sides by x, which gives us the x cosine 48 equals 10 line. Then, to figure out what x is, you divide both sides by the cosine of 48. So you're going to have 10 in the numerator, and then cosine 48 in the denominator. Lastly, you're going to plug that into your calculator, and then you get the 14.9448. So this one, to find the value of x, is going to be a little bit more involved, but I think you'll be all right with that. That's it for this one. I know this one was a little bit longer, but we got through those 5 examples. So after you take a break, come on back and watch examples 6 and 7. They'll be in the next video on word problems. Thanks for watching this one, and I'll catch up with you guys soon. Have a great day. Peace.